At 4:37 a.m. of March 14, 1957, a supply boat cleared the dock at Morgan City, Louisiana, and turned south into the Atchafalaya River, bound for a drilling platform in the Gulf of Mexico, 60 miles offshore. The run would take 4 to 5 hours, depending on weather. The boat carried drilling mud in tanks below the waterline, fresh water in separate tanks, casing pipe on the open stern deck, and a manifest of dry goods and food in the small covered cargo hold forward. The platform crew had been on station for 14 days. They were low on mud weight and out of a specific grade of cement. The boat's captain had made this run 43 times in the past 8 months. He knew the channel markers from Morgan City down through the bayou system to the open Gulf. He knew where the shoaling was. He knew which platform his dispatcher had assigned him. And he knew the tool pusher on that platform would be watching the horizon by the time the boat was within visual range. This was not unusual. Somewhere in the Gulf of Mexico, at that same hour, dozens of supply boats were making similar runs from Houma and Morgan City and Intracoastal City, each one carrying something that a platform needed before it could keep drilling. The offshore oil industry in the Gulf of Mexico began in 1947, when Kerr-McGee placed the first platform out of sight of land, 43 miles southwest of Morgan City in 18 feet of water. What no one had fully solved at that moment was how to keep it supplied. The answer took nearly a decade to find. And when it arrived in the form of a boat whose design had never existed before. When Kerr-McGee placed Kermac Rig 1643 miles southwest of Morgan City in 1947, the supply question was answered by whatever was available. Old Navy vessels, converted shrimp boats, oyster luggers from the Louisiana bayous. None of these were designed for the job, and the job itself was barely defined, because no one had operated a drilling platform in open water before. No one knew exactly what it would consume and in what quantities. What became clear quickly was the scope of the dependency. A drilling platform is not a ship. It does not move toward its supplies. Everything the platform needs to operate, drilling mud, cement, casing pipe, drill collars, fuel, food, fresh water, spare parts for machinery running 24 hours a day, has to come to it. And if the supply run is delayed, or if the wrong cargo arrives, or if the weather shuts down offloading, the drilling stops. Before we go further, if this kind of story matters to you, consider subscribing to the channel. Every video here is built around the systems that actually moved America. The rail yards, the port operations, the industrial facilities, the infrastructure that most people never thought about until it stopped working. Every offshore oil platform in American history has been kept alive by a supply boat running through the night from a Louisiana dock. And most people who fill their gas tank have never heard of the system that made it possible. Did you or someone in your family work supply boats in the Gulf of Mexico, or on the docks at Morgan City or Houma? What company ran your vessel? And what class of platform were you running to? The scheduling and cargo logistics system that Morgan City developed for Gulf supply runs in the 1960s became the operational template for every offshore oil province that opened anywhere in the world over the next 30 years. And this channel intends to follow that story. Now, back to the system. The problem with every vessel being used to supply offshore platforms before 1956 was not power or range. It was deck space. A conventional workboat or converted fishing vessel carried its wheelhouse amidships or aft, with cargo space forward. That arrangement made sense for vessels that needed to maneuver with a deck officer watching the bow, but it cut the usable cargo deck in half. On an offshore supply run, cargo was the entire point. Drilling pipe, drill collars, and equipment came in lengths and configurations that required long, clear, unobstructed deck space to stage and secure. A vessel that put its wheelhouse in the middle of that space was carrying half the cargo it could have carried. Alden Dock Laborde solved this by inverting the arrangement. The wheelhouse went to the bow, the crew quarters went to the bow, and everything aft of the superstructure was open stern deck. A long, flat, clear working surface that could be loaded from the dock and discharged at the platform without interference from any fixed structure. The hull below the waterline carried tanks, dedicated compartments for fresh water, fuel, liquid drilling mud, and dry bulk cement. Each system independently plumbed and pumped so that liquid cargoes could be discharged without moving deck cargo and without the mixing of incompatible materials. The vessel Laborde and his brother John designed and built to test this concept was the Ebb Tide. Tidewater Marine Service, Inc. was incorporated on February 7, 1956. When Shell Oil and Phillips Petroleum heard about the new boat, each immediately requested a vessel of their own. The wheelhouse forward supply boat was not an improvement on what existed. It replaced what existed with something that had not existed before. The cargo manifest of a Gulf of Mexico supply boat run in 1960 was not a simple list. It was a precise inventory of materials in incompatible categories that had to be carried simultaneously, stored without contamination, and discharged in a specific sequence at a platform that had no dock, no crane other than its own, and no margin for receiving the wrong material. Liquid bulk was the foundation. Fresh water, thousands of gallons per run, for the platform's drinking and sanitation systems. Diesel fuel for the generators and cranes. Liquid drilling mud, called base fluid, pumped from shore tanks into the vessel's dedicated mud tanks and pumped back out at the platform through hoses deployed over the rail. Dry bulk cement, loaded into pressurized tanks aboard the vessel and discharged by compressed air into the platform's cement silos. On the open stern deck rode the solid cargo. Lengths of drill pipe, drill collars, casing sections, sacks of dry drilling chemicals bagged and palletized, food and supply boxes for the platform galley, machinery parts, replacement equipment, and whatever specific hardware the tool pusher had called for on the last radio contact. None of this cargo could be mixed. A contamination of fresh water by drilling fluid or of fuel by cement dust could compromise the platform's entire operation. The vessel's crew was responsible for the integrity of the manifest, from loading at the dock through discharge at the platform. When a hose was connected to the wrong tank fitting, when it was the vessel crew that paid for the consequences. Not in money, but in the tool pusher's assessment of their competence, which determined whether that vessel got the next contract with that drilling company. The cargo was the relationship. The relationship was the business. Every supply boat that left Morgan City carried a manifest. But the manifest was not assembled by the vessel crew. It was assembled by a shoreside logistics organization that had to reconcile what every platform on the company's Gulf of Mexico contract list needed, what was available at the dock and in the warehouse, what could be combined into a single run without exceeding the vessel's cargo limits, and which platform was most critical. By the early 1960s, the supply vessel companies, Tidewater, Zapata, and the growing fleet of smaller Louisiana operators had developed shoreside dispatch systems that ran around the clock. A dispatcher's board tracked the location of every vessel in the fleet, which boats were underway, which were at platforms, which were at dock, and which were available for the next assignment. Radio communication with platform tool pushers and with vessel captains at sea fed a continuous update of what each platform required and when. The scheduling constraint was not simple. A platform that needed a specific grade of drilling mud by the start of the next shift could not wait for a vessel that was already committed to a different platform. A vessel loaded for one destination could not easily be diverted to another without either returning to dock for a different manifest or arriving at the second platform with cargo the tool pusher hadn't ordered. The shoreside dispatcher was, in operational terms, the equivalent of a railroad classification yard tower operator, managing the routing of cargo through a network in which the nodes moved and the destinations changed. The difference was that a misrouted freight car sat on a siding. A misrouted supply run meant a drilling platform waited on its next bit of hole. The Gulf of Mexico is not a benign operating environment. It is a body of water that produces tropical storms and hurricanes, sudden squalls, dense fog, following seas that make cargo handling dangerous, and beam seas that make offloading at a platform a physical problem requiring precise boat handling and crew timing. The supply vessel fleet of the 1950s and 1960s operated in these conditions without the weather routing systems, the forecasting tools, or the vessel stabilization technology that came later. A captain departing Morgan City on a fair morning in September could be running through 12-foot seas 6 hours later as a tropical disturbance developed over the Central Gulf. The vessel could not wait the disturbance out at the platform. There was no place to moor, and it could not always return to port. The sea state behind it might be worse than what lay ahead. It kept moving, and it worked the conditions with what it had. Hurricane season, June through November, imposed a planning constraint on every run from every dock on the Gulf Coast. A platform that needed a supply run on August 14th received that supply run as long as the captain assessed the passage as survivable. When he did not, the platform waited. And a platform crew that had cut their fresh water supply too fine before a 3-day weather delay discovered what offshore dependency meant in its most fundamental form. The consequences of a weather-forced supply delay were not catastrophic if the platform's inventory was managed correctly. The consequence of incorrect inventory management, when weather closed the Gulf for 72 hours, was a drilling halt that cost the operating company its day rate on the platform without producing footage. The captain's sea state assessment was, in that moment, the most expensive single judgment call in the offshore supply chain. Moving cargo between a supply vessel and an offshore platform was a problem of physics and seamanship. Moving people was a problem of a different kind. A supply vessel does not dock at a platform. There is no pier. The vessel holds position alongside the platform's lower deck or boat landing, a steel structure that may be 6 to 12 feet above the waterline at low tide and submerged in heavy weather. The vessel rises and falls with the sea. The platform does not move. The gap between them opens and closes continuously. In the early years of the Gulf supply industry, crew transfer was typically accomplished by the personnel basket, a large wire cage or net structure suspended from the platform crane lowered to the supply vessel deck, loaded with workers, and hoisted back up. The basket required the vessel to hold position close enough for the crane to reach, the crane operator to time his lift to the vessel's rise, and the workers in the basket to hold on without being caught between the basket and the platform structure as it swung. It was one of the more dangerous routine operations in the offshore industry. A platform crane operator who misjudged the timing and lowered the basket onto a vessel deck as the vessel rose could put tons of load on workers who had nowhere to go. A basket that swung against the platform jacket structure could injure or kill the occupants. The alternative, the personnel boat or crew boat, transferred workers by vessel, motoring alongside the platform boat landing and allowing workers to step directly across. This required even more precise vessel handling, because the step across was done while both surfaces were in motion in different directions. In the Gulf of Mexico in the 1960s, this transfer happened hundreds of times a day, every day, across the entire platform fleet. The men who ran the Gulf of Mexico supply boats in the 1950s and 1960s came primarily from two backgrounds: the commercial fishing fleets that had worked the Gulf for generations and the United States Navy. The fishermen brought seamanship, the practical knowledge of Gulf weather, of tidal patterns in the bayou system, of small boat handling in open water that no training program could fully replicate. They knew how a boat behaved in a following sea and what a Gulf sky looked like 3 hours before a squall. They did not have formal maritime licenses in the early years. The Coast Guard licensing requirements for the offshore supply fleet were developed over time as the industry formalized. The Navy veterans brought something different, an understanding of naval logistics, and of how to manage supplies in a system where demand was continuous and unpredictable, and of the discipline required to maintain a vessel on a schedule regardless of conditions. Both groups converged on Morgan City. By the late 1950s, Morgan City was the economic and logistical center of the Gulf offshore supply industry. The boatyards that built OSVs, the warehouses that staged cargo, the dispatch offices that managed the fleet, and the boarding houses where crews between rotations lived were all concentrated in a small city on the Atchafalaya River, whose population had not prepared for the industry that arrived in its backyard. A deckhand on a Gulf supply boat in 1962 was earning wages that compared favorably with any other marine employment on the Gulf Coast, while working 2 weeks on and 1 week off on a schedule that put him on the water for the equivalent of 8 months a year. The physical demands were unceasing: loading, offloading, securing, line handling, anchor watch, and the continuous maintenance that any working boat requires just to remain operational. The rotation schedule was how the industry kept its workforce functional. The Gulf would not slow down. The people had to. In 1956, the Gulf of Mexico offshore supply vessel industry consisted of a handful of companies operating a small fleet of purpose-built boats and a larger number of converted vessels of various origins. Tidewater Marine was the acknowledged originator of the purpose-built OSV, but the demand it had identified grew faster than any single company could serve. By the early 1960s, the supply vessel companies, Tidewater, Zapata, Secor, and scores of smaller Louisiana operators, were ordering new vessels as quickly as the Gulf Coast shipyards could build them. The standardization that had been implicit in the labored design evolved into a series of recognized vessel classes: the smaller crew boats that moved personnel, the medium supply vessels that handled most platform cargo runs, and the larger flat-deck boats that could carry the heaviest equipment: derrick materials, blowout preventers, subsea wellhead components. As Gulf production moved from shallow water into deeper water through the late 1960s and 1970s, the vessels grew. A platform in 150 feet of water required more anchor chain, more riser pipe, more drilling equipment than a platform in 30 feet. The supply runs got longer, the cargo got heavier, and the vessels had to have the range and deck capacity to match. The international expansion followed the drill bits. When oil companies moved offshore operations to Venezuela, West Africa, the North Sea, and Southeast Asia, the supply vessel companies went with them. Tidewater was operating in Venezuela by 1958. The Morgan City model, purpose-built vessel, dedicated shore base, or scheduled dispatch system, became the operational template for every offshore oil province that opened anywhere in the world over the next 3 decades. A logistics system developed in a small Louisiana city on the Atchafalaya River became the global standard for a new category of marine freight. What Alden and John Laborde built in 1956 was not just a boat. It was a logistics system for a new kind of industrial operation, one that existed at a permanent remove from its supply base, in water deep enough that land was not visible, in conditions that could change without warning, and with a dependency on continuous resupply that allowed no margin for the failure of the supply chain. The offshore supply vessels solved a problem that existed nowhere else in American industrial history. The railroad had its classification yards. The trucking network had its highway interchanges. The port had its pier infrastructure. The offshore platform had a steel deck in open water, thus connected to shore by the boat that showed up when it was scheduled and carried what the manifest said it was carrying. The industry that grew from Morgan City over the following decades became one of the most demanding marine logistics operations ever developed. By the 1970s, the Gulf of Mexico offshore fleet numbered in the hundreds of vessels. The companies that ran them, Tidewater, Zapata, and a second and third generation of Gulf Coast operators, had created an operational standard for offshore supply logistics that was replicated with local variations in every offshore oil province that followed: the North Sea, West Africa, the Persian Gulf, Southeast Asia, the South Atlantic off Brazil. Every one of those global operations was traceable, in its organizational logic and its vessel design, to a company that was incorporated in Delaware on February 7, 1956, and to the first vessel it put in the water, the Ebb Tide, outbound from Morgan City on a pre-dawn run to a platform in 18 feet of Gulf water. The platform needed drilling mud by the start of the next shift. The boat had it. That was the whole system. If this story gave you a clearer picture of what held these systems together and what it took when they came under pressure, subscribe to the channel. There are more yards, more ports, more operations, and more decisions still to document. Every offshore oil platform in American history has been kept alive by a supply boat running through the night from a Louisiana dock. And the men who ran those boats built a marine logistics system that became the template for the global offshore industry. And if you have a connection to this kind of work, a relative who ran supply boats in the Gulf, a parent who worked the Morgan City docks or the dispatch office, someone who was on a platform when a weather delay stretched the fresh water supply to its last day, tell us in the comments. What company ran the vessel? What platform were they on? What did they say about the run when they came back to shore? The most complete record of how these systems were built and run isn't in any report. It's in the people who were actually there.